Okay, so let's start. Let's continue our discussion on 555 timer. As we discussed last week, we have seen very important device, general purpose integrated circuit. We call it 555 timer or 55 timer IC. So today we'll see the three basic modes of operation for 555 timer. 555 timer has three modes of operation: bistable mode, astable mode, and monostable mode. So we'll discuss the three modes of 555 timer. So you can use 555 timer in bistable mode for many applications. You can use 555 timer as IC in astable mode for many applications. Also, you can use 555 timer as monostable mode for many applications. So it's very important to understand what these three modes of 555 timer: bistable, astable, and monostable. We'll discuss these modes one by one, but before that, let's see what does it mean by bistable, astable, and monostable. So as you know, the output of a 555 timer, output of a 555 timer. So pin number 3 is our output, as you can see here on the slide. So this output of a 555 timer can be high or low. Okay, no other options. As we have discussed, the output of 555 timer at pin number 3 can be high state or low state. High means on, low means off state. You can call it like that, or you can call it 1 and 0. So this output can be high and low, depends on what? Depends on the inputs we apply to the 555 timer. Depends on the inputs. This output of the timer can be high or low. So what are the inputs? The two main inputs for a 555 timer are trigger, pin number 2, trigger input, and pin number 6, we call it threshold inputs. So based on these inputs, we apply at pin number 6 and pin number 2, we can control the output. The output can be high state or low state, depends on these two inputs. As we have discussed, there is another input also, control voltage, pin number 5. In some applications, we use also pin number 5, control voltage, in order to control the output at pin number 3. So always keep in your mind, 555 timer, the output can be high state or low state. No other option. Okay. So when you come to the three modes of operation, the first mode, we call it bistable mode. So let's say this is the output of the timer. So the output, as I said, can be on and off. So initially, let's say the output of this timer is high state. Okay, it is high state, and it remains high. It remains high until we apply external input to change the state. Otherwise, it remains high. It does not change this high state. So this is a stable. Stable state means the output cannot be changed unless you apply external input. So this state, which is the high state, remains high until we apply what? let's say we apply here input. This is input. Okay, where we apply input at the this is the output of the timer. So inputs pin number 2 and 6, trigger and schedule. So here we are not applying any input. Without applying any input, the output remains at high state. It is stable. Now, when you apply at this time, when you apply input, let's say at pin number 6, we apply small input here at pin number 6, threshold input. When you apply input, it changes to low state. Okay. Then it again remains low state. It does not change by itself. It is stable. By means what? 2, right? By means 2. So two stable state means both high and low are stable, which means the output of, if you configure 555 timer in bistable mode, in order to change the output from high to low, we have to apply external input. Without applying, it remains stable. It remains unchanged by itself. So look here, this high, the output of this timer is high state. It is on, so it is stable, right? Until we apply what? When you apply this input at pin number 6, the output changes from high to low state. Now what will happen? Again, this state is also stable. Stable means, as I said, it will not change. It remains the same unless you apply external input. If you are not applying, it remains off. It remains off. Okay. Now, when you apply trigger here, another input, let's say at pin number 2, trigger input, the output changes now from low to high. Now it becomes high. Why it changes? Because we apply input. Without any input, the output remains stable. Stable means it does not change by itself. Okay. So let me show you this by okay, so when you see this bistable mode of a 555 timer, this is bistable mode. I will explain the circuits later, one by one. But now I want to understand. Look here. This is bistable mode of this 555 timer. Now the output is on. It does not change. You can see the LED is on, which is connected to pin number 3. Pin number 3 is output. So it is bistable. Bi means 2. If it is on, it remains on. When you change input, when you apply input, it changes to low and it remains low. To change it again to high, you need another input. So both states are stable. Both high and low states are stable. That's why we call it bistable. Okay. So now to change this, you see it's still on, no change, because the high state is stable. To change it, we apply input here at pin number 2. You can see here, pin number 2 and pin number 6 are inputs. Okay. My input devices are here a switch. One switch for pin number 2, one switch for pin number 6. Now when you click this switch, when you click this pin number 6, now the LED is off. now it is off state. Off state is also stable. You see the LED, it remains off unless what? Unless we apply input at pin number 2. So to change, now it's low, the output is low state. To change it from low to high, we apply input here. Now, without applying input, the output remains the same. That's why we call it bi-stable mode. So you can configure 555 timer in bi-stable mode. Okay, so it does not change from high to low by itself. The states are stable. That's why bi means 2. 2 means high and low. The 2 states are stable. Once it is low, it remains low. To change it to high, we need another input. Okay. Now you can see when you apply input, it changes state, and it remains off. When you apply, it will change state. So both states are stable. That's why we call it bi-stable mode. Next mode is astable mode. In this case, in this mode of operation, the output is astable, means it is both states are not stable. In this case, this is the opposite to bi-stable, which means the output for some time it remains high and it changes without applying any input. In astable mode, without applying any input, the circuit itself changes from high to low. For some time it will be high, then changes to low, then high, it changes to low, like this. Is there any input here? No, the circuit does not need any input. It turns on and off based on the circuit. Okay, this type of mode of operation of 555 timer is called astable mode. So if you see if you see this astable mode of 555 timer, as you can see here, the output, the LED, turns on and off without applying any input. The circuit itself generates on, off, without applying any input. So such type of mode of operation of a 555 timer is called astable mode. I will explain these circuits later one by one. Okay. Okay, this video also you will see 555 timer in astable mode. So in astable mode, we need a timer. This is a breadboard. Now we connect the 555 timer IC here. This is external capacitor. I will explain why we connect this capacitor resistors for this 555 timer. This is pin number 1, 2, 3, 4, 5, 6, 7, 8. It is 8-pin device. Now pin number 3 connected to output, light emitting. There you see here pin number 3, 1, 2, 3. Pin number 8 goes to VCC, power supply. Pin number 1 goes to ground. You know pin diagram of a 555 timer. This is astable mode. We don't need to give input to change the state. You see here, the timer now on and off by itself. The output changes the state from high to low, from low to high by itself. So both states are not stable in this case. High state is not stable, which means at some time it changes. Low state also is not stable, it changes to high at some time. Depends on this time for on and off. I will come to that later. Depends on the capacitor charging, discharging time. We'll come to that. But now I want you to understand the on and off of this timer, pin number 3, is astable. It changes from high to low. But when you come to bistable, the first one, look here, it does not off. It remains on, which means this state is stable. To change it, we need to give input pin number 6. Now it remains off continuously without change. To change the state, I have to go to pin number 2 and click input. Why? Because it is a bistable mode of operation. Okay. When you come to astable mode of operation, the if I have a stable mode, let me check. Okay, here I have astable. Astable means you can see without me applying input. Look, this LED. Now it is on. Now it is off. After some time, it will be on. Now it is on. Look, the blue light emitting diode, which is connected to pin number 3. I am applying any input? No. By itself, it changes states from on and off, on and off. Okay? So both states are not stable. At some time they change. Then it will be off. At some time it changes by itself. This mode of operation is called astable mode of operation. Astable mode can be used in many applications like computer clock generation and advertising light systems. We'll come to that later, the circuit. So this is astable mode. So far we have discussed what? Bistable and astable. Now third one is monostable. So in monostable mode of operation, okay, so mono means one. Okay, look here, in bi means 2, right? Mono means 1. So bi means 2. So to change high to low, we need input. To change low to high here, we need another input. How many inputs needed for bistable? 2 inputs. Here, astable means no input at all. In this case, no inputs is needed. Both high and low changes by itself. For bistable, we need how many inputs? 2 inputs. Right? 2 inputs at pin number 2 and at pin number 6. To change high to low, again low to high, we need another input. In monostable case, mono means 1. So the output is high state now. You see, it is at high state. It is stable, means it remains high. It continues high. Unless we apply what? Input. When you apply input, immediately when you apply input, it changes its state. It changes its state from high to low. Okay, it changes its state from high to low. But low state is not stable. By itself, at some time period, it goes to high. You see, I am not applying any input. It changes from low to high by itself. How about high? It is a stable state. It remains on unless we apply some input. It remains on. So it continues to be on state. The output is binary 1. So to change it, we need to apply input. When you apply, it changes from high to low. But to change it from low to high, we don't need input. It changes by itself. Now, which state is stable? The high state is the stable state. Stable means, as I said, it remains in that state unless we apply external input. How about the low? Is it stable? No, it's not stable. It's not stable. What does it mean? After some period of time, without applying any input here, it changes that state. That's why it's not stable. So how many states are stable in this case? 1 state. That's why it's called monostable. Okay? Mono means 1. So let me show you. Okay, this is monostable modes of operation. The timer is configured in monostable mode. Let's see. Now we have only 1 switch here, not 2 switches. Okay. Now when it remains 1 state unless we apply the input. Look here. Now it is off. Off state is stable. When you apply input, it will change the state. Okay. Okay. Let's see. Do I have monostable? I don't have monostable. You can do it on. Okay, so this is, I think, a stable mode. This is a stable mode, yes. This is our oscilloscope. You see here, is it astable, monostable, or bistable? This timer is configured in in astable mode. You can see the light emitting diode on and off by itself. You can see the output. In this oscilloscope, you can see oscilloscope is connected to pin number 3. It is on, off, it changes by itself. In bistable mode, to change from high to low, we need input. To change from low to high, we need another input. So we need how many? 2 inputs. In monostable, only we need 1 input to change it from high to low. Okay, but from low to high, it changes by itself because mono means one state is stable, the other state is not unstable. For astable, as you can see here, astable, we don't need any inputs. It changes from high to low by itself. That's why we call it astable mode of operation. So these are the 3 modes of operation for 555 timer. Okay, so as you can see here, for a stable case, the output changes from high state to low state. We don't need any trigger, no input. It changes from high to low, high to low. When you come to monostable mode, we need 1 input here. So it remains, this is now the stable state. This is stable, okay? Stable. The low state is stable. Low, this is low. Now when you apply input, it changes from low to high. Now high, this is unstable state. Why it's unstable? It changes by itself from high to low without any applying input. We are not applying any input here. Okay? It changes from high to low by itself. So the low state is stable here. Look here. To change from low at high, we need input. It changes from low to high. From high to low, no input. Now it remains low. You see, low, it remains low until we apply inputs. So which state is stable? The low state is stable, the high state is unstable. But in this case, both are unstable. High changes to low without any input. Then low goes to high. This is low state. This is high state without any input, so no input is needed. This case 1. How about bistable case? Bistable case, we have 2 inputs. How many inputs for bistable multivibrator? We have 2 inputs. Input 1 here, input 2 here. How about astable multivibrator? We don't need any input. It changes from high to low by itself. How about monostable? We have only 1 input. Look here. When you apply input, it changes state. But to change from high to low, no input. Now it remains off. The output remains off until we apply input. If you apply input here, now the state will change. So this is a stable state. That's why it's called it monostable multivibrator or monostable mode. So you can configure your timer as astable, monostable, or bistable modes of operations. Okay. So let's start from the bistable mode. So what does it mean by bistable mode? Let's draw bistable mode here. So what's pin number 8? Pin number 8 is VCC. So I connect here my VCC battery. You remember pin number 8 is power supply unit. So let's say we apply 12-volt battery here, right? Pin number 4 is reset. if you are not using pin number 4, we connect it to VCC also. So pin number 4 and pin number 8, VCC. How about 6 and 2? 6 and 2 are inputs. This is called trigger input. This is called threshold input. Now we are not using pin number 7. Okay, for bistable multivibrator, we are not using pin number 7. How about pin number 1? Sorry. So bring your battery here, VCC. Connect pin 8 to battery. So let's apply 12 volts. Okay. Now pin number 6 and pin number 2. So these are 2 inputs. So I connect one external resistor, 10 kilo ohm, and my input, in this case, I'm going to use a switch, okay, to pin number, what's pin number 1 in timer? It is our ground, okay? So this pin number 2 connected to the switch, okay, one of the inputs. So you can use here 10 kilo ohm resistor, 10 k external connected to pin number 2. Pin number 1 is ground. What's pin number 5? It's control voltage. We are not using control voltage. So always, if you are not using control voltage, ground pin number 5 through 0.01 microfarad capacitor to ground, because we are not using it. Okay, pin number 5 is a special type of input. In bistable mode, we are not using pin number 5. We are not using pin number 7, discharge. Pin number 7 is called a discharge pin. We are not using it. We are discussing which mode? Bistable mode. Bistable means the output at pin number 3, which can be high or low state, changes from high to low. We need input. To change from low to high, we need another input. Okay, 2 inputs to change one state, because both states are stable in this case. So how many inputs we need? 2 inputs. So one input, we give it to pin number 2 here. What is our input? Our input is this switch. You see this switch? Okay. As I said, pin number 8 is power supply. Always in our pin diagram, when you see pin diagram of a 555 timer, pin number 8 is power supply. Pin number 1 is ground. We are not using pin number 7. We are not using pin number 5. For bistable, how many inputs we need? Pin number 2 and pin number 6. This is our output. Reset also, we are not using pin number 4. So we connect it to our battery. If you are not using pin number 4, we connect it to the battery. That's what I am doing now. So how about another input? Pin number 6. So I connect another switch to which input? To pin number 6. Okay, then through a resistor you can ground it. Okay, now it's grounded. Which is ground? Pin number 1 is ground. Pin number 8 is battery, 12 volts. How many inputs now? One input here, another input here. This input connected to pin number 2, which is trigger. This switch is connected to another input 6, threshold input. You see how simple it is? So now if you connect your light emitting diode, as an example, you can connect any other device. this, if you connect your light here, this will be either on or off state, right? Always timer can be 1 or 0. The output at pin number 3. So to make it on, it needs input. To make it off, it needs another input. Because both states are stable. Stable means without applying input, it remains the same. So the output remains on. When you apply input, it changes. And now it is off. It remains off because it is stable. When it changes, when you apply another input, it changes. It becomes on, and it remains on until you apply another input. So it needs 2 inputs to change the state. 2 inputs. That's why we call it by. By means 2. So let's see how it works. So how many switches? One switch here, another switch here. So this is very. Look here, it shows you internal circuit of a timer. To understand how it works, in this case, I didn't show you the internal structure of this timer, but here, it showed the internal structure of a timer. So as you know, timer, as we have discussed last class, it has first this 3 resistors, 5 kilo ohm, 5 kilo ohm internally. So this 3 resistors, 5 kilo ohm in series, connected from pin 8, which is our battery, to pin number 1, which is our ground here. So the voltage you apply at this point, VCC, is, here we have, as we have discussed last time, how much? 2/3 of VCC. Here at this point, we have 1/3 of VCC. Okay, so how much voltage we apply at pin number 8? 12 volts. So look here, VCC is how much? 12 volt battery. So this 12 volt battery voltage divided into 2 by these resistors in series, 5 kilo ohm resistors internally. So how much voltage we have at this point? It is 2/3 of VCC, always, as we have discussed last time. So how much VCC? 12 volts. So how much voltage here? 2 divided by 3 times VCC. VCC is 12. So how much? It will be 8 volt comes here. Okay. Now, at this point, it's only 1/3 of VCC. So 1/3, how much battery we connect? 12 volt. So how much voltage comes here? 4 volt. Okay, that's the first state. Always in timer, the first subsystem we have discussed is this voltage divider. This voltage divider. So whatever battery you apply is divided into 2/3 and 1/3. 2/3 connected to the first comparator, 1/3 connected to the second comparator. So what is the second part of a timer? This comparator part. Okay, so let's go to our bistable mode. So look here. So here we have second part, comparator C1 and comparator C2. So comparator C1, 2 inputs, right? Always when you see comparator device which has 2 inputs, so check which one. If the positive greater than negative, output will be 1. If the voltage at the negative terminal is larger than the positive terminal, output will be 0. This is how comparator works. So in this case, 8 volt comes here at the negative. Comparator C1 at the negative, we have 8 volt. Where this 8 volt comes from? From the battery divided into 2/3 by these resistors and goes to at the negative terminal of C1. Okay. Now when you go to, when you see comparator C2, 4 volt is fixed, which comes from the power supply 12 volts divided into 3 by these resistors. Where are these 3 resistors? Internal to the timer, there are 3 resistors in series. So whatever battery you apply, they divide into 2. 2/3 given to first comparator, 1/3 given to the second comparator. Okay, now let's see comparator C1 and C2. What is the positive input? Pin number 6 for comparator C1. For comparator C2, pin 2 is the negative input. We are in 555 timer, we have 2 comparators, comparator C1 and comparator C2. Okay, so C1, first comparator, compares 2 things. 1, pin number 6. Whatever you apply at pin number 6 goes to the positive terminal. Here comes from where? Pin number 6. It comes here. What is another negative terminal? Which comes from the voltage divider, from the battery. 2/3. Always it is 2/3 of VCC. In this case, VCC is 12 volt battery. When you multiply by 2/3, it will be 8 volts fixed. Okay. Second comparator, 4 volt, the positive one, always comes from the divider. How much? 1/3. Always 1/3 of the battery. Battery in this case 12 volt. 1/3 of 12 volt. 4 volt is fixed here. Which terminal? The positive terminal of comparator C2. How about the negative terminal? Connected to pin number 2. You see, we have 2 comparators. Comparator C1, check your input at pin 6. Comparator C2, check your input at pin 2. The 2 inputs connected to the 2 comparators. Okay, now, so as we have seen, this is 8 volt fixed. This is how much? 4 volt from the battery divided. Now let's see C1 and C2 comparators. Now, here you see pin number 6 is connected to VCC through a switch, right? When the switch is off, it's connected, no connection to VCC. So how much voltage here? It will be 0 volt. Okay, 0 volt. Similarly, this switch is off. Okay, this switch is off. Now, pin number 2, if this is on, pin number 2 here, pin number 2 will connect to ground. When this is off, pin number 2 goes to what? Goes to VCC, battery. Depends on the 2. Okay, so look here now. This is how much volt? 8 volts from the divider. How much here? 4 volts. Okay. So let's say this switch is at off. Off means how much voltage at pin number 6? It's off means no connection to the battery. So we have 0 volts. So what will be the output of comparator C1? 2 inputs. Which one is larger? The positive is 0, negative is 8. So which one is larger? The positive is, sorry, the negative is larger than the positive. In this case, output will be 0 for the comparator C1. Now let's come to comparator C2. Now the switch is off. So pin 2, is it connected to VCC or ground? Because this switch is off, pin 2 is now connected to the VCC. What is VCC? Our battery. So how much voltage? How much voltage? VCC, battery, 12 volts. Now, which one is larger? The negative is larger, right? So negative is larger. This will be how much? 0, right? Now, when you turn on this, when you turn on this switch, let's start from this switch, okay? Let's start from switch number 1. This is switch number 1. Now switch number 1, make it on. Switch number 2 is off. So when you press this switch, we give at pin number 6 12 volt. Okay, here this 0 volt becomes what? 12 volt. Why? Because we give a switch at this position. Now this connected to VCC, so 12 volt comes here. Now which one is larger? This is, I told you, is 8 fixed. So now positive is larger. When positive larger, this becomes 1. Okay. Now when you see next device is SR flip-flop. The SR flip-flop here. Okay. So when S is 0, R is 1, Q bar, we are using Q bar, not Q. So it will be 1. This is a truth table. When S is 1, when R is 0, Q bar will be 0. This is the truth table for the flip-flop. Okay, for the flip-flop. Now look here. How the comparator C1 connected to reset R. Comparator C2 output goes to set. So what is R now? R is 1. What is set? Set is 0. So when S is 0 and R is 1, what will be the Q bar? Q bar will be 1 here. So 1 goes to the inverter, which inverts 1 into 0. So the output will be what? 0. Off. Okay, at off state. It's bistable. To make it on, what we should do? We have to make sure this switch make it on. When this is on, this switch off. Let's see now the change. Switch 1 is now off. Switch 2 becomes on. Okay, let's see now the output changes or not. So when it is on, pin 2 connected to what? Connected to ground. So this voltage will be 0 volt. Pin 2 will be 0 volt. This is off. So pin 6 also will be 0 volt. Okay, what will happen in this case? Let me show you again. Second case, this switch is off. Now we give input here. This switch is on. So how much voltage at pin number 6? Because this is off, pin 6 is not connected to battery. So how much voltage? 0 volts. How much volt comes to the negative terminal? 8 volts. From the battery divided into 2, it will become 8 volts. Now what will be the output of C1? Because the negative is larger, C1 output will be 0. Now let's come to C2. This is on, means pin 2 connect, because this is shorted. When you short it, the pin 2 directly goes to ground. Ground means how much voltage? 0 volts. How much here? 4 volt fixed. 1/3 of VCC will come here. Okay, so what will be the output of comparator C2? Positive is greater, 4 greater than 0. So this will be 1. So 1 connected to the set S. This comparator output goes to reset. Now, so what is set now? Set and reset. If you see the trace table, if reset is 1, always Q bar is 1. When set is 1 and reset is 0, Q bar will be 0. Okay, this is a truth table of SR flip-flop. Now R is what? R is 0 here. And what is S? S is 1. So what will be Q bar? Q bar will be 0. Now this 0 comes to the inverter, 0 converted into 1. Now the output becomes what? On. Previously it was 0, now it becomes on. Okay. To change it from off to on, I make this switch here on. Now again, it will be remains on. To make it off, I have to give this input again from another direction. It needs two inputs to change from on and off. From off and on, we need one switch. From off to on, we need another switch. This is what we call it a bistable mode of 555 timer.